Okay, I want to welcome to the fourth video of your free Introduction to Spring course. Now, in the previous videos, we looked at creating a brand new Spring Boot project right from Spring Initializer, where we set up a new web application. And in the last video, I showed you how to use dependency injection, which is truly one of the powers of Spring, and to rapidly do this. And dependency injection is a very important part of Spring, but what makes Spring so popular for enterprise use and cloud scale use is a lot of its auxiliary projects and how it's designed to handle distributed architectures. And to segue into this, one thing I want to talk about is the templating engine called Timeleaf. I have a course in Timeleaf, and occasionally I'll get a student inquiring about Timeleaf and saying, hey, I heard Timeleaf was slow. Now, if you look at benchmarks, Timeleaf does come in slightly less performant than, say, JSPs or Velocity or FreeMarker, some of the more established templating engines. It does come in slightly slower. The benchmarks vary, but it's usually 20-30% slower in number of page views. Now, what you have to take into account for these benchmarks is you got to take them with a little bit of a grain of salt, because what they're going to do is measure number of pages rendered by the templating engine per minute is a pretty common metric. Now, there's a lot of things that can happen to affect that system-wise. The JVM, the load on the system, other load on the system, just how the page is being set up, the client, the network. So a lot of things can come into play that affect the benchmark. CPU speed is one of the biggest ones. So if I run a benchmark on my computer and you run one on your computer, I might be using, well, I am using OS X. You might be using Windows. Chances are that the benchmarks will be different because we're running different CPUs, we have different memory, we have different operating systems. So you're going to see benchmarks vary quite a bit, but when you're running on the same hardware, benchmarking the same technologies, it is a pretty good indicator of how performant that is. Now, I segue into these benchmarks because what I want to tell you, in modern Spring development and modern web development, it's not that big of a difference, not that big of a deal if you have a templating engine slower than one. And I'm going to explain to you now exactly why that is, because you as an end user are not going to pick up that difference. So a lot of these benchmarks, from the top of my head, you're looking at about 1,500 page views per minute. And if you're cranking out 1,500 pages per minute and you have another one that's only doing 1,300 per minute, now you as the end user, when it's generating pages, there's no way that you're going to tell the difference in rendering speed. So you're talking fractions of microseconds between the two pages. So as an end user, whether it's in Timeleaf or JSP or in search templating language here, as long as you're relatively same, you are not going to be able to tell the difference. So these benchmarks are designed for a single server, and in large-scale web applications, that's not what you always have. So I'm going to go over and sketch this out to explain it a little bit more and switch context here. All right, to help you visualize what's going on a little bit better, a lot of times what you're going to have is an app server, and that's going to be followed up with a database server. So we have a very simple single application server talking to a database, and this is what you're going to see a lot in the benchmarks. Especially, this is going to be similar to like a WordPress site, where you have the application running in the classic LAMP stack, and to scale it out, what you'll see a lot of times that we'll move the database to its own dedicated server and give its application its own dedicated server. So you have those compute resources there. Now, this is a good approach, and this is where you're going to see benchmarks. Now, if this was our world in web development, especially, it's really not Java specific, but if I had something running slower, then that benchmark would definitely be an issue. But that's really not the case, because what we see often is we'll take the database server and we'll load balance it, or we'll do multiple app servers, and they'll all talk to that same database. And what's going to happen here is we can scale this out as much as we need to, up to the capacity of that database. And then we can do stuff like doing a cache layer in here, so we alleviate the workload off the database, try to handle things real time in memory, only hit the database when we really need to. And what this is going to do is, if, let's say, this one here is a little bit slower, or this one here is a little bit slower, now in that benchmark where we're 20-30% slower, it really doesn't matter, because we're able to scale these out horizontally and add in more app servers to the capacity of the database, and that's going to handle the web traffic. So you as the end user are not going to be able to really perceive the difference in a small differential, or a small delta in the benchmark of that application. So when we say that TimeLeaf is a little bit slower than a traditional JSP page, that is correct. But when you look at load balancing technology and scaling out the application tier horizontally, that delta becomes less and less important. Now, this approach is pretty cool. It's really a old school type approach to get scalability out of a system. And as I pointed out, that database is really going to be a thorn on our side when we try to get into massive scalability. Now, the Spring framework is often used to achieve massive scalability in a cloud type environment. And what I'm showing you here is not really a cloud type environment. So let's take a look at a real high level architecture of how Spring would be used. So if we had our cloud out here of requests, now a lot of times what you're going to see is a load balancer that the requests are going to come into. And this load balancer is going to distribute the load across multiple nodes. So I'm just going to do 2 nodes here. And if you're in a big enterprise, this is probably going to be an F5 load balancer. And those things are like crazy expensive, but they do stupid volume. This is something like eBay would run, or an Amazon.com would run at their website. And that's going to go into additional web servers. And what's going to happen there is these servers, just like what we saw before, now in the age of microservices, they're going to be backed up with microservices of their own. And these are going to just keep going out. And in this type of architecture, now we could actually have like 3, and these tiers, they become dynamically scalable. So in the age of microservices, like this tier here, whatever that microservice happens to be, we could run 1 node of it, we could run 3 nodes of it, we could run 100 nodes of it, all depending on the load that's coming through the website. And when you get into a cloud architecture like this, you're going to be dividing and conquering. And this is really where the Spring framework really shines. Now, you do have the original tool set to do a single tier architecture like we're looking at before. But where Spring is really getting into a lot of traction is building these massively scalable applications and websites where you're getting into microservices, and you do have to separate things out and have microservices that you can dynamically scale up and down. Like think about a Netflix that consumes a ton of bandwidth, and they run on Amazon's infrastructure, but they're all microservice based, and they spool these things up and down, all according to the load on the services. And this is the area that the Spring framework is just gaining a lot of traction because of the tool sets the tools within the Spring framework. Okay, now this is a true story. Just a month or so ago, I'm talking with a Java architect from Wells Fargo, and this guy claimed to be an architect, but he didn't know very much about scalability. We got into a discussion about AngularJS. Now, I like AngularJS. It's a very cool technology, doing a lot of really cool stuff with it. So I'm still learning it myself. I'm kind of functional with AngularJS, but I'm far from an expert in AngularJS. And this Java architect for Wells Fargo told me he thinks the industry is moving to where everything's going to be written in AngularJS, and it'll be all done on AngularJS, and it's just going to be accessing microservices that are going to go into the back end and just update a database record. So there's really not going to be much on the back end. Everything's going to be moving towards the client side in AngularJS. And he was absolutely wrong on this. And I was rather emphatic with him because he was so wrong about this statement. Now, AngularJS is cool technology. I'm not bashing AngularJS at all. I like AngularJS. It does a lot of stuff. And his mindset really reminded me of back in the 90s when everybody went client server and we said, hey, we need to offload everything to the client. We have these new PCs and they can do so much cool stuff. We're going to write applications on the client side and have them do all the stuff and offload the server so we don't need these massive mainframes all the time. And that prediction was also wrong. It's a good habit to have very rich and robust clients do. There's a lot that you can do on the client side where you don't need that processing power on the server, but you are going to be far from just updating a database. And on the server side, you're still going to have a lot of complexity there. And with this Java architect I was talking to, I shot him down right away. I hate to use the term shot him down, but shot down that idea that the world was going to AngularJS and we're just going to be updating records on a database or a microservice on the server side. I was like, okay, what about checkout? How are you going to do checkout? What do you mean? Well, if you're doing checkout in a large enterprise website, you're going to have an address verification service. You're going to do some type of standardization. You're going to be calling out to a credit card processor probably multiple times because you're going to do an auth or a pre-auth and auth on the credit card transaction. So several transactions are going to occur. So you're going to be interacting with different services. It's not just a database that you're talking to. You're not just going to be updating a record. There's going to be services on the back end, and all this needs to be coordinated. Now, if you are Amazon size and have massive scalability, this gets exponentially worse because you are not just updating a database. You are going to be talking to service layers, going through caches, in-cloud memory, data grids, all kinds of stuff. When you get to massive scalability, it is far removed from just a simple database update. So he was very wrong in this. I was a little disappointed that someone who had the job title of Java architect saw this way. And I can understand the mindset of thinking that we can push everything to the client side. So this Java architect probably had never been exposed to large scalability systems. So if you're used to smaller systems, yeah, you probably could think that. But out in the real world, in the enterprise, you have extremely complex backends that you get in for the scalability. And you do see in the industry, in my lifetime of working with Java and Spring, another thing that I've seen come down the pike is where somebody predicts the end of Java, how Java's an old language, quote unquote, air quotes, old language, and it's coming to its end. And this is another thing that I do not see. Java continues to be the #1 language because the language has evolved through time. The curators of Java, who's now with Oracle, have done an outstanding job of keeping the language current. Sometimes they fall behind the curve a little bit, but if you look at Java usage, when Java 8 came out, you can see a serious uptick. And there's some very important features in Java 8, like functional programming, functionality that was added to Java 8. And now this kind of made the Java language more modern, and enterprises have not only continued to adopt it, they're continuing to use it more, and Spring is being used more and more in the enterprise for this. All right, now the first major paradigm that's going on in IT computing right now is cloud computing. And cloud computing is a very abused term. I had a debate with a CEO that said that they were doing cloud computing because he moved his stuff up to a cloud provider and virtualized his servers. Now that is not cloud computing. So you're not taking any advantage of the cloud architectures if you've just virtualized your server. So it's a very important architectural paradigm shift to be doing cloud computing. Like my Spring Framework Guru website runs on AWS, in air quotes, in the cloud. the website is not doing cloud computing. Gmail runs in Google's cloud. That is doing cloud computing because Google is running hundreds, if not thousands, of nodes in separate independent services, and any one of those nodes can go down and easily be replaced by another. So they can dynamically scale up and down, and they have a tremendous amount of scalability and reliability. So that's what I mean by cloud computing, is when you have a distributed architecture that like that and not just a virtualized server. So in contrast, on my springframework.guru website that's running WordPress on a virtual server in EC2, if that server goes down, my website stops. Google, on the other hand, if they lose a server or probably even a data center, Gmail is going to stay up and keep working. Now, the other important trend that is happening in cloud computing is microservices. This is kind of a recent trend in software development, is to be developing microservices. So this is a huge buzzword right now to develop microservices. And there's a lot of advantages to doing microservices. Now, Spring Boot has tools built in, especially like Spring Boot Actuator, has tools built in for the management and development of microservices. And this is a trend that's not going to go away. When you put these two together, cloud computing and microservices, you have a very scalable architecture. Working with a client right now that does high volume processing of medical claims, like hundreds of thousands per hour. And we are developing that using microservices. Like one of them just does parsing from these different EDI formats. That's a microservice, and we can dynamically scale out that microservice. So the microservice is going to be very specialized and dynamically scalable. We're writing it in Spring Boot, and we're actually standing it up in Kubernetes, so we have dynamic scalability and redundancy. So it's a really cool architecture that we're implementing there. Now, the next trend that we need to look at is functional programming. Java 8 added a lot of functional programming features to it. And what we're going to hear in the Spring industry in 2017 is a lot about reactive programming. And this is a whole paradigm shift in how we handle our programming tasks. So without getting into too much, functional programming is a paradigm shift. Now, you take these three technologies together, cloud computing, microservices, and functional programming, it's going to make you a lot more productive as a developer. You're going to be building much more scalable architecture. So this is going to be the trend for some time. And Spring itself is well positioned to take advantage of this. They are focused on a lot of massively scalable applications. Like MongoDB has a reactive interface that we can work with to stream data out of a Mongo database, and we can use that in a reactive design pattern. So this is, right now when I'm talking about this, it's early 2017. This is all stuff that's being developed. The Spring stuff isn't released yet, but this is coming for us. So I expect this is going to be here for some time. This is a trend that's not going to go away. And these are like three very powerful paradigms that are coming together. And I assure you, Java and Spring are going to be core to the continuing trends in 2017 and beyond. Okay, I'm very excited about these trends in technology. I've seen the industry grow and change quite a bit in my 20-something years in IT and doing software development and delivering enterprise-class applications. And I remember the day when you had to buy a $300,000 server, and now we have that compute power on our iPhone. So it's absolutely insane. The technology and options and choices that we have today are very exciting. The capabilities that we're forming and developing, especially with the three trends that I just explained between cloud computing, microservices, and functional programming, mean that these frameworks and technologies are coming together where you can build a very scalable application very quickly. That's really becoming surprisingly how effective you can be. But all this stuff isn't easy. There's a lot of facets to it. Now, I've been developing courses around the Spring framework, and I do have courses that will take you, it's kind of like a zero to hero type approach, where I'll start you off step one, you'll just be doing a hello world type application. The classic hello world, we did that early in the course. That's like one of the first steps in my paid courses. But we progress from there. We progressively build upon that. So at the end of the sequence of courses, you are going to have a Spring Framework website up and running, if you choose, up on EC2. So you'll deploy on Red Hat Linux, preferably. You can use CentOS also, same thing but different. But you can use both of those. You'll have a website up and running, and in the process, all along the way, I am going to be teaching you things that industry normally does, enterprises normally do, why you use a Spring Framework, why you configure Spring differently, how you support different environments. And don't forget, this is used by big companies, and these companies are going to have very demanding requirements where you might want to develop on an H2 in-memory database on your laptop, and in QA you're going to have maybe a MySQL database, and in production you might be using an Oracle database. How do you accommodate for that? How do you take, at best practice is to have one binary artifact, move it from your build server and across all the different environments? How do you accommodate that? That's something I'm going to show you exactly in my courses. And I've got a lot of exciting content. I'm actually adding a lot of content. I'm recording a lot of exciting stuff right now, doing a lot of stuff with Docker. It's really kind of cool stuff you can do with Docker. And I'm bringing this cool technology into my courses. It's to give you leading edge technology and trends in the industry. So tomorrow, I'm going to send you an email. Watch for my email, and in this email is going to have a special offer on my courses. So should you want to continue learning the Spring Framework like thousands of people have already done with me to advance their programming careers, you'll be able to take that next step and advance your programming career.